This is the practice for section 6, 7. Numbers 1 through 10, you're going to use the distance formula and find an answer. Round your answer to the nearest hundredth. That's 2 decimal places. Keep your eyes open for the easy ones. 11 through 13, these problems are a little bit different. So we're going to talk about each of these. Is triangle XYZ with vertices, X, Y, and Z given, is that a scalene triangle? Well, scalene triangles have 3 side lengths that are all different. So what you need to do is use your distance formula 3 different times to find the lengths of those segments. And then compare them. If they're all different, then it's definitely scalene. Okay? So you're basically doing a very easy problem like one of these, but you're doing it 3 times in one problem. So it's a little bit time consuming. So I kind of had this already written out for you. You want the distance from X to Y, so you're using these ordered pairs. You want the distance from Y to Z, so you're going to use those ordered pairs. And then you want the distance from X to Z, so you're going to use these ordered pairs to find these lengths. Now, the one nice thing about this is, if you look at the ordered pairs for Y and Z, notice how the X's are the same? So that means how far is it from 4 to negative 5? You know that's 9. You don't need to write that out and use a distance formula. Okay? But we are going to do it for the other problems. So how far is it from X to Y? Let's figure that out. We're going to do negative 3 minus 2 squared. And then we're going to add that to our Y values. 1 minus 4 squared. And that's going to give me this answer, 5.83, I'll call it. Now, we're going to do the same thing for the distance from X to Z. And notice here, I already have the same X values here, negative 3 and 2, negative 3 and 2. So what I'm going to do is I'm going to hit this second button, and then I'm going to hit the Enter button, and it's going to give me the same thing I just typed in, so I don't have to type it in again. But this time I'm going to do 1 minus negative 5. And you might need to insert INS, second, delete, to insert a character. So you're not typing over the thing that you want to keep. And that gives you this distance, 7.81 we'll call it. Look at those 3 lengths. These are side lengths of a triangle. Is the triangle scalene? Yes, it definitely is. All the side lengths are different. Number 12 is the same type of problem, except they're asking you is the triangle isosceles. Okay, so you're looking for 2 sides to match. Well, again, we want distance from R to S, we want distance from S to T, and we want distance from R to T. So I kind of have the coordinates already there for you. S to T, notice how the Y values are the same. They're both 1. So how far is it from negative 4 to positive 2? It's 6. Let's type these into the calculator and see what we end up with. So this is distance from R to S. I'm going to do negative 1 minus negative 4. Then I'm going to do 5 minus 1. And that gives me a length, oh, you didn't even see any of that, did you? You're going to get a length of 5. So far it's not isosceles because those don't match. But what I am going to do is find the distance from R to T. Now I can do the whole second enter thing again, even though I'm using coordinates here that don't match the one from before. I need a negative 1 minus 2. So I'm going to come over here and make this a positive 2. I have to delete the negative. Okay, so again, delete that, not clear it. Oh, cleared the wrong thing. All right, so you need that to be a 2. And then on the other side, we got a 5 minus 1, which is what we wanted. That's what we had over here anyways. That gives you 5. Is it isosceles? 2 of the sides match. That's a yes. Last one. Determine if this triangle is a right triangle. So again, let's find the lengths of those 3 segments. How are you going to know if it's a right triangle? Well, remember the converse of Pythagorean theorem? Do these three side lengths make a right triangle? So you're going to do these three problems, then you're going to do one of those converse problems. Okay, so let's find these lengths. And actually, it's probably going to be easier to not get the answer as a decimal here. It's probably going to be better to leave it as a radical. Okay, so here's what I'm going to do to type this in. I'm not going to type the radical in. I'm just going to type in my parentheses. -3 minus 2 squared plus -4 minus -5 squared. And that's going to give me 26. So really, this distance is not 26. It's the square root of 26. But that's easier to work with than a decimal that I would have gotten. It would have been like 5.0, blah, 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 a whole bunch of crap. Okay, let's do the same thing for distance from E to F. I'm going to do 2 minus 0. I know that's 2, and 2 squared is 4. So I'll just do 4 plus -5 minus 1 squared. And that gives me 40. Now again, it's not 40, it's the square root of 40. But the square root of 40 is a decimal. It would be like 6 point blah, 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 a bunch of crap. D to F, let's do the same thing. -3 minus 0 is -3. And -3 times -3 is 9. So I know I got 9 plus something. -4 minus 1 is -5. And -5 times -5 is 25. So if I just do 9 plus 25, I get 34. Square root of 34. Now these are the exact lengths. Do these make a right triangle? Well, if it was going to be a right triangle, which side is the biggest? That guy is, right? So here's what you want to know. Square root of 26 squared plus square root of 34 squared, does it equal the square root of 40 squared? And you might look at that and say, I don't know. But it's actually very easy. Remember, the square root of 26 times the square root of 26 is just, kind of out of room here. I'll move over here. It's just 26. What's the square root of 34 times the square root of 34? It's just 34. What's the square root of 40 times the square root of 40? It's just 40. Now, if this equals this, then it's a right triangle. 26 plus 34, is it a right triangle? Definitely not.